Hello, everybody. Welcome to Code Vipassana Season 9, Session 4. This is the last session of the season, the last Code Lab. But don't worry, we'll be coming back very soon with another season. We hope all of you have enjoyed all the Code Labs, all the sessions. The Code Lab we're doing today is all about setting up Toolbox for our GenAI and agentic applications on AlloyDB. We have worked on a similar application last Code Lab, but today we'll show you how to make it easier and another way to do it. Let's get started. A little bit of overview about the lab. GenAI Toolboxes for Databases is an open source server from Google that makes it easier to build GenAI tools and interacting with database. What this helps us do is it helps us simplify development, have better performance, get access to enhanced security, and have end-to-end observability. This toolbox sits between our application's framework and the database and provides a control plane that is used to modify, distribute, or invoke tools. What we're going to do in this lab, we will be installing Toolbox, we will be setting up the tool, then we will deploy it on Cloud Run, test it in Cloud Run, and build the Cloud Run function to invoke the toolbox. The requirements are very simple. All you need to do is work in a Chrome or Firefox browser and have a Google Cloud project with billing enabled. Let's get started. Before we begin, we have to navigate to the Google Cloud console and select a Google Cloud project. I already have my Google Cloud console open here. To go to your Google Cloud console, you can type in console.cloud.google.com and you will be led to your Google Cloud console. To select a project, click on this icon. You will have a list of projects that you could work on. If you wanted, you could just create a new project. I am choosing this project, test-code-vipassana. Make sure you know your project ID. In my case, it is the same as my project name. Yours can be very different or it can be anything else. You can also copy your project ID from your always the home page of your Google Cloud console. Make sure you have billing enabled and we're good to go. Let's get started. There are a set of commands that we need to follow. For these, we'll be using the Cloud Shell inside Google Cloud environment and we have to activate it. I'll show you how to do that. We have to click on this icon, the one right beside the Gemini icon. Let's click on that. And we can open this in a new tab. Let's authorize it, open it in a new tab, go back to the previous tab, close it, come to the Cloud Shell, authorize it. Why have we opened this in a new tab? Because a lot of time building a lot of things, we require the Cloud Console page to be separate and the terminal to be separate. Using this method, we can always have our terminal set and active in one tab when we can do other things in the other tab. So let's run the command the Code Lab asks us to. The first command we have to run is gcloud auth list. This will tell you if your terminal is connected to your Google account or not. Let's press enter. You can see it says active account and my email ID. So that means we're good to go. The next command that we have to run is gcloud config list project. This will tell you if your terminal is connected to a Google Cloud project. Since it is not set to a project right now, you can try using the next command, which is gcloud config set project and project ID. You will always find this command on the top of your terminal, on the top of any terminal you use in Google Cloud Console, and you can use this for setting your project ID. Let's type in the command gcloud config set project ID. Remember, you could always copy your project ID from this page. Let's copy it, paste it, and press enter. You can see the property has been updated and now I can see my project ID inside the terminal. Let's get started. We need to require some APIs to enable them inside the Cloud Shell terminal, but a better way to do this instead of pasting all of these one by one is using a hyperlink on the word link. What this helps us do is it helps us enable all APIs together without any worries. Let's click on the hyperlink, paste it in the tab where we have the Google Cloud Console open. You can see it asks us to click next and it will enable the following APIs. The AlloyDB API, the Cloud Run, the Vertex AI, and so many more. This will help us build our project and enable all these APIs in a very robust manner. When your button is grayed out, you can be assured that all your APIs have been enabled and you can continue with the code lab. Let's go back to the code lab and press next. Now, we'll be setting up the database. In this lab, we'll be using AlloyDB as the database. AlloyDB uses clusters to hold all of the resources such as database and logs. Let's get started with the code lab. We have to create a cluster and an instance. The most easy way to find AlloyDB in Google Cloud Console is by searching it from the home page. I'll show you how to do that right now. Let's go to the home page, click on the search bar and type in AlloyDB. You can see this is how your AlloyDB page would look like. If you have all the APIs enabled, this is the page you'll be greeted with. If you don't have it enabled, don't worry, just enable the API and you should be seeing this page. We need to create a cluster. Let's create a cluster. And now we have to configure some settings. Let's go back to the code lab and see what settings these are. We have been given multiple things to configure, like the cluster ID, password, the compatibility, etc. Let's copy and make this cluster accordingly. The cluster ID should be vector-cluster, so that is what we'll be using. The password should be AlloyDB. The database version has to be Postgre 15 compatible. The region has to be US Central 1, Iowa. The networking can be left on default. As you can see, we have everything like this. Currently, I am not seeing this icon of setup connection because my connection has already been set up. But if you need to set up your connection, please follow the steps here. You can click on the setup connection button and you can select use an automatically allocated IP range. Click on continue and create the connection. You will be able to create the connection. Once our network is up, let's set the cluster. We can set this cluster as any ID. I am going to be choosing the ID that is given in the code lab, which is vector-instance. You can choose any ID you want, but make sure to remember this ID since you'll need to change it later. Rest assured, everything leave it on default and we're good to go. Let's create the cluster. The cluster will take some time to get created. You can go through the code lab in this time, see what is going on. You can see the cluster has already started getting created. You can see on the bottom right the progress of creating your instance of the cluster. Even though it shows ready here, it is not necessarily ready because the Google Cloud Console is still in the process of creating your cluster. Don't worry, wait for a little bit, it will happen. We will currently fast forward this process. It will take about 7 to 8 minutes to create your cluster and the instance. But please note, if you already have a cluster like this created with a similar ID from the last code lab, you can delete that cluster from the AlloyDB settings and start all over again without any issues. Make sure that you have submitted the results of the previous code lab before you delete that instance and start again with this one. As you can see, it took about 7 to 8 minutes to create our instance of the cluster, and now we can move forward. Now that we're done creating the database and the primary cluster, we'll be using AlloyDB to ingest and add a table and the data and use this cluster for all our operations. Let's go to the Google Cloud Console, navigate to AlloyDB, select the database as Postgres, user as Postgres, and remember the password that we had set, AlloyDB. Let's copy that, paste it, and authenticate. Currently, you will have 0 tables inside your database. That is because this is a new cluster, but don't worry, that is what we're going to do next. Firstly, we'll be enabling 2 extensions, namely pgvector and Google ML integration. These extensions help us store and search vector embeddings and provide us the function to use Vertex AI prediction endpoints for getting predictions in SQL. Let's copy the DDL command, open a new tab called editor, paste it, and click on run. You can use these editor tabs to run any kind of SQL query, whether it is DDL or DML. Let's now check if the extensions were created successfully. This command will show us all the extensions that we have in this database. The good news is we have the ML integration extension and the PG extension, so we're good to go. The next step is using the DDL command below to create the table toys. This table will hold all our data from ID of the toy to the name, description, quantity, text embeddings, image URL, price, etc. etc. Let's click on run. The statement is executed successfully, and you can see in the Explorer on the left side, the table toys has been created with 7 columns. Now, to ingest the data, we'll be using the SQL file that is hyperlinked on the text SQL file. But note one very important thing, that we'll only be using the first 5 lines to insert data into this database and table right now, because to generate embeddings, which is the next step, we don't want to waste too much time. Let's paste the 5 lines here, click on run, and statement has been executed successfully. To view how your table looks like right now, you can just execute a simple SQL query, which is select star from toys limit 2. Limit 2 basically tells the SQL query that only show me 2 records. If I click on run, it will show me 2 records from our current table. Let's go back to the code lab and proceed to the next step. The next step is all about granting permissions and roles. This command is to give execute rights on embedding function to the user Postgres. Let's copy the command, paste it inside our editor, click on run, and you can see that was successful. Now to grant the Vertex AI user role to the AlloyDB service account, we'll need to run the following 2 commands in our Cloud Shell. Let's copy the first command, go back to the Cloud Shell. You can see we already had it open. Press enter. The configuration is set. Let's copy the next command, press enter, and you can see the permissions were successfully given, as it says the permissions were changed and we're good to go. You can see right here updated IAM policy for the project test-code-vipassana. So let's move on. The next step is all about creating embeddings for context. Think about embeddings as a sense of representation for any kind of text. It can be a sentence, a word, English, Chinese, any language. All it has to be text, and what the model will do is convert it into a bunch of floating point numbers. You want to see how they look like? Look at this screenshot. The entire description or the quantity or anything can be converted into embeddings just like this. This to the model makes sense and represents this text data that makes sense to us humans. To generate the text embeddings, we'll be using the model text-embedding-005. Let's copy this command and generate embeddings for our 5 records. We'll click on run. You can see the statement is running and it has executed successfully. We'll move forward to look at the table, and you can see we have our embeddings right here. It has 5 columns that stands for all of our, it has 6 columns that stand for the 6 columns and their embeddings. So we're good to go. Okay, now let's perform real-time vector search. Let's say I want to ask the system, I want a white plush teddy bear with a floral pattern. How we can do this using SQL is we can use the following command. Select star from toys, select the entire row for this command that matches the order by command by text embeddings, which is casting our text embedding model and our query. If we click on run, you can see all of these matched our query, and that is the result that we get for this test. This is what happens at this query in detail. You can read it if you like. For this, I will be skipping it and moving on to the next step. Now, we'll prepare AlloyDB for the Toolbox interaction. Firstly, we'll have to enable public IP connectivity in our AlloyDB instance so the new tool can access the database. Let's go to the AlloyDB instance and click on Edit and edit the primary instance and checkbox enable public IB. Let's go back to the overview section. Let's click on edit primary, enable public IP. Let's see what we have to do next. To get the IP of a Cloud Shell machine, we'll have to go to the Cloud Shell terminal and enter ifconfig. From the result, we can identify the ETH0 INET address and replace the last two digits with 0.0 with a mask size /16. For example, this is how it would look like. You can see this is our ETH0 flag and this is our INET. That is what we need to select from the ETH0 INET address and replace the last two digits with 0.0 and a /16. So let's go ahead and do that. Let's take our INET address 10.88.0.4, 10.88.0.4, but remember to replace the last two digits with 0.0. So this goes and 0.0/16. Next, we can click on update instance and it will take a few minutes to complete. You can see it is updating the vector instance. It will take some time to complete and it will be done very soon. We will fast forward this section of the video too. This will take another 5 minutes of your time. It will update the instance and then we'll be ready to go to the next step. Now, let's move on to step 8, which is Toolbox installation. We can create a project folder inside our Google Cloud Console and work with this. So, we will make the folder Toystore inside our Google Cloud account. Let's go ahead and do that. Go to the terminal, paste the command mkdir toystore, which stands for make directory toystore. It will make that directory. Then we will copy cd toystore, which says change directory to toystore. You can see now we're inside the toystore folder. The next command is we export the version as 0.1.0. Let's press enter. Then using the curl command, we will install the Toolbox server inside of our folder that we just created. And then finally, we'll give the Toolbox server execute permissions by using the command chmod +x. Now, you can see it asks us to toggle to the Cloud Shell editor and expand the newly created folder Toystore and create a new file called tools.yaml. Let's do that. It's very easy to toggle to the editor. All you need to do is close the terminal, click on open editor and open workspace. You can see I have my app here, Toystore. I click on OK and there it is. The toolbox we just installed. If you don't get the open workspace option, don't worry. You can simply go to file, open folder and select Toystore from there. Now, a few things to do before you get started. Make sure your terminal looks something like this. You click on terminal, new terminal, so you don't have to toggle again and again between the terminal. Let's set our project here, gcloud config set project test-code-vipassana, and our project will be set. This is Gemini Cloud Assist. It can help you if you get any errors, if you need to ask it anything, ask it about any commands, code, etc. etc. Very helpful for Google Cloud users. Let's move ahead. Now, we need to create a new file called tools.yaml. Let's do that. Tools.yaml and copy paste the contents from here into the file and change the your project ID with our actual project ID. In my case, it is test-code-vipassana. In your case, it can be anything. Please note, while creating the vector instance in AlloyDB, if you selected your vector instance as anything else other than vector-cluster and vector-instance, this is the place you'll have to change it. We can make more changes to this file to modify the search, but let's move on right now. Now, let's go to the Cloud Shell terminal and enter the following command to start the Toolbox server with the Toolbox configuration. Let's copy the command, go to the terminal and press enter. You can see it has initialized and the server is ready to serve. Now, if we open the server in web preview mode, we should see that the Toolbox server is up and it is running with a new tool called getToyPrice. How do you open something in web preview mode? You go to the top right, click on this icon that says web preview, preview on port 8080, and you can see it says hello world. So we're good to go. Now that we have tested the application, before we move to the next step, I would just like to tell you one thing. If you have faced an error that is something like this, let's say you deployed the application, it shows you server ready to serve, but when you click on web preview and you click on preview, it shows you the server is not able. I will just show you the error. Let's say my port was 8080 as shown in the video right now, and it shows you this message, unable to forward your request to a backend. That probably means you're on the wrong port. When you're running the toolbox, you can be on the port 5000. So how you can fix this is you can go to web preview, click on change port, click on 5000 and change in preview. And you can see hello world just like I could have few minutes ago. So now we're ready to move to the next step. You can press Ctrl C to exit and shut down the server gracefully, and let's move on. The next step is to use Cloud Run and deploy our toolbox on Cloud Run. We'll be following the instructions in this page. The word page is hyperlinked to a series of instructions that will help us deploy our toolbox on Cloud Run. Let's go and use those instructions, and please follow my steps very carefully. Now, this is the page that will open up if you click on this link. Before we begin, we need to install the Google Cloud CLI. Thankfully for us, we don't need to do that since we're already on the Google Cloud console, and this is our Google Cloud CLI, so we don't need to do that. Let's go ahead. We need to set the project and ID environment variable. We will copy this command, paste it inside our terminal, replace my project ID with the actual project ID that we have. In my case, it is code-vipassana-test. Press enter. You can see that the ID has been exported. I'll just clear the terminal a little bit so we have a lot more space. Let's go and look at the next command. We don't need to initialize the Google Cloud CLI or set a config project. If you can see this project ID right here, it means your project ID is already set and you don't need to do it again. There are some APIs that we need to enable. We've already enabled some of these in the start, but it's always a good practice to copy and paste the command in case you missed any API. Let's copy paste the command, press enter, and you can see it tells us it has a successful message. So we're good to go. Okay, now that we're done enabling the APIs, the next steps is to grant some permission IAM roles inside our IAM account and have the following roles. IAM service account creator, secret manager admin, and service account user. One very important thing. How you can do this is go to console.cloud.google.com. In the search bar, search for IAM, press on the tab. A page will load in front of you. If you are using the same Google account as the owner, if you are the owner for this account, then you don't need to enable any of these permissions since they're already given to you. But keep this page open. We will need it for enabling some other permissions and giving access to some other roles. Let's move ahead. Let's create a backend service account. Let's copy and paste this command inside our terminal. Let's paste the command, press enter. It has created a service toolbox called toolbox-identify created service account. Now, The next command is to grant permissions to use secret manager. Let's copy the command, paste it inside our terminal. As I told you, if you're the owner of this Google account that you're using, and this is the Google account the project was created in, you will already have all these permissions. So you will be able to give secret manager access to the account. If I press enter, you can see that we are able to give secret access to this account. Let's move ahead. Now we need to grant some additional permissions to the service account like AlloyDB, Cloud SQL, etc. etc. How we can do this is come back to our Google Cloud Console, go back to the IAM tab, refresh it, and you can see we'll have an extra thing here called Toolbox-identify and your project ID. Currently, it only has one role, which is Secret Manager Secret Accessor. We'll click on this Edit Principal button and add a few more roles that are needed for this project. Okay, let's start adding all the other roles. What you need to do is click on Add Another Role. The first role that we want to add is Cloud AlloyDB Client. This will help the app access our AlloyDB instance and give it the client permission. You can see I have found Cloud AlloyDB client. I'll click on it and it's been added. Now I want to add another one. So I'll click on add another role and I'll search for service usage consumer. You can see service usage consumer. It gives the user ability to inspect service states and consume quota and billing for a consumer project. Great. A last role that we need to add is simply a viewer role. Let's type viewer, the first option, viewer. It helps us to see the list of included permissions. These are the 4 IAM permissions you would need inside your toolbox-identify service account, and your IAM page should look something like this, where you have these 4 permissions, these 4 roles for this account. Let's go back to the Cloud Shell and continue following the steps. You don't need to configure a tools.yaml file since we already configured a tools.yaml file. We can simply move ahead for deploying to Cloud Run. Let's copy this command. Again, I'll clear it up a little bit, paste it in the terminal, press enter. You can see it has created the secret tools. Let's move ahead. Copy this command, paste it, wait for the output. That's also done. Let's export the image, the Docker image, under the image variable. Let's go ahead and do that. It's been exported. And finally, let's build the application. If you have done the last lab, you know we followed the VPC network method, which is something like this. But because we're using the toolbox, which is much more easier this time, all we need to do is copy this command, build our application using it, and deploy it on Cloud Run. Let's hit enter and it will start building our application. You can see it will take very little time and just start right now. You have to click on allowing unauthenticated invocations. So just press Y and press enter. This is very important. And now it is deploying a container to the Cloud Run service. Please make sure that you have given all the necessary roles and permissions to the service account. Only then will this step be successful and you will be able to deploy this on a Cloud Run service. It will not take much time and in some minutes it should be done. It is creating revision right now, deploying the service toolbox inside our project code Vipassana test in the region US Central 1. You can see we've successfully deployed the toolbox application on Cloud Run. It has given us a service URL. If you click on control or command and click on this link, you'll be able to open it. And there you see the same hello world, but on a toolbox URL that is created. That's great. Let's move ahead. We are done with this page. We can close it, move on. We're done with this step. We are ready to deploy our newly built application. Now, in this part, we will build a small application to test our tool and interact with the application's need and retrieve a response. What we can do is go open a Google Colab notebook in the same place where we have our Google Cloud Console open. Let's go to that page, click on collab.research.google.com and start a new notebook. First, we need to install some dependencies, which is pip install toolbox langchain. If we're using pip, make sure you have an exclamation mark here, which tells Collab that this is not a shell command, this is a terminal command and it will use pip to install toolbox-langchain. Once it is successful, we can move ahead with the rest of the code. You can see it has collected it, downloaded it, and it is currently building it. Successfully installed Toolbox, and you can see we have a tick mark right here. Let's go and select another cell and paste the rest of the code. From the second line all the way till the end, copy, paste, and run. As you can see, I have gotten an error, which I purposely did because now what you have to do is you have to replace this part of the command with your service URL. We can go ahead and do that. We can copy this URL from our terminal and press and paste it here. And now if we run the same thing, we'll be able to get a result. You can see its price is $15.99, exactly shown to us in the code lab. Pretty cool. Let's click on next. Now we'll take this to the cloud. We'll take the source code from the code repo folder for getting this serverlessly to Cloud Functions. What we'll do is we'll open the hyperlink of Cloud Run Functions in the same tab here, and we'll add a new Cloud function. If it doesn't load in the first try, just maybe hit a refresh and it should load. You can see we have it right here. We'll keep it unauthenticated for the demo application and copy the main and requirement files as needed. Let's configure this. Let's give the service name as Toolbox. The US region should be US Central 1, Iowa. Toolbox Cloud Run, Iowa. The runtime we want is to be Python 3.10, or we can keep it as 3.112. So let's go ahead and do what the code lab tells us. Let's keep it as 3.11. Allow unauthenticated invocations, and we can leave the rest on default. Let's click on create. You can see it doesn't take much time to create the application. The traffic has been routed and we have our Cloud Run set. Now what we need to do is we need to change the code inside the main file and the requirements.txt file. We can get the code from the GitHub repository that we just opened. Let's go ahead and expand the toolbox-toys folder and the Cloud Run Functions folder, and you can see we have both the files main and requirements. Let's copy the main file, go ahead, edit the file. You can see we have our entire file here. Once we replace this code, we'll need to go to our Cloud Shell, copy our service URL, go ahead and paste this inside here to make sure it is taking our toolbox client. Then go to the next file, which is requirements.txt, copy these requirements, paste it inside our requirements file, and save and redeploy. You can see we've saved and redeployed the instance. It's been redeployed, and now we have a URL which we can use. It is currently building and deploying the service in Cloud Run. This will take some time. Don't worry, it will happen very soon and you will be able to use your application on this public URL. Let's stay tuned for this. You can see the build and deploy has been successful. And now if we go to the app, we can see price 49.99. You can also test this application out. We can go to the test tab and test it as per our commands, which is search is our command. And let's say maybe I want to search for a white plush toy. I think that is the same thing our code lab asks for. It asks for it in a different way. So let's just copy the white plush toy and paste it here. Okay. Now if we test this in Cloud Shell, you can see it's initializing the Cloud Shell. It's searching for white plush toy and hopefully it gives us the value 49.99. Great. It has given us the price 49.99. Our cloud function, Cloud Run, works serverlessly and our app is ready. We've taken it to the cloud and finished the code lab. Congratulations, you have successfully created a robust and truly modular tool that can interact across databases, platforms, and generative AI orchestration frameworks to help create your agentic applications. Here at Code Vipassana, we hope that we've helped you to learn a lot of new things, a lot of new technologies, and hopefully a lot of new concepts like Toolbox, AlloyDB, vector search, embeddings, and so many more. If you love what we're doing, follow us on Instagram, LinkedIn, YouTube, show us some love. We'll come back with another season very soon. Thank you so much. See you again soon. If you have any doubts related to this session or any of the past sessions, please reach out to any of our Code Vipassana leads on Discord and we'd be happy to help you out. Thank you so much. Hope you had a great time.